to hanging out, messing around, and geeking out. Today, Tom Lowers is going to present the Hummingbird Robotics kit, and we're going to start to put it together. Maybe we'll finish, maybe we'll have to continue this and see how it is programmed using a visual programming language. So why don't we introduce ourselves? John, why don't we start with you?
Sure. My name is John Umekubo. I'm the Director of Technology at St. Matthew's Parish School in Pacific Palisades, a little suburb of Los Angeles. I also teach a class called Creator Studio. It's a 7th and 8th grade elective class about just sort of designing, building, and iterating. I'll put the website up for anybody who's interested on the thing here.
Okay, great.
That's it.
And John, feel free to use the Geek Out platform for your classes. You don't have to be me to start a Geek Out.
Terrific. That's really great. Thank you.
It's meant to be a platform for peer learning. Paul, welcome.
Hi. Yep.
Hi. You want to introduce yourself
Norway.
briefly?
Yeah, I'm Paul. I'm calling in from Norway. Following Howard on these Geek Outs for a couple of months now. Looking forward to this Geek Out.
Hey, Paul, we're gonna do a continuation of that Geek Out we started with the Funduino robotics kit. Feel free to join it. Take a look at the Homago site, and you'll see a place to sign up for it.
Yeah, I'm signed up for that.
Okay, great. Peter, would you like to introduce yourself?
Sure. I'm Peter Kittle. I teach English at California State University, Chico, and I direct the Northern California Writing Project. And we're doing lots of stuff with incorporating technology and literacy. So excited to know more about the Hummingbird kit. And Tom, we emailed back and forth yesterday a little bit.
Yeah.
So hi.
Hi.
All right.
Great.
Okay, so Tom, take it away.
All right. So my name is Tom Lowers, and I'm the owner of BirdBrain Technologies and the developer of the Hummingbird kit. I want to give you a brief history of the kit. It came out of a Carnegie Mellon research project called Arts and Bots that was housed in the Robotics Institute. And we started that project way back in 2006. And I was a doctoral student then working on the project. And our initially what we were trying to do was develop a robotics activity around arts and crafts materials and specifically targeted towards middle school girls. Now, since then, we've expanded the project quite a bit. At this point, it's really about kind of creating robots with arts and crafts in elementary, middle, and high school, and just using robotics as a platform to engage students in all kinds of learning, but also as a way of kind of sneaking engineering, design, and programming and computer science into the core curriculum, where, you know, at least at the elementary and middle school level, it's rather hard to see, you know, engineering, design, and computer science taught to most students, you know, you know, as part of their regular school day. So we're hoping to use Hummingbird as a platform for kind of inserting those concepts into just a regular classroom experience. And also, I guess, the idea of putting making into that classroom experience. So we've had the Hummingbird kit commercially available for 2 years now. So that's 6 years after the research started. I mean, it took us a long time to get there. We started with participatory design sessions with middle school girls. We moved on to working with like a local YWCA and local homeschool groups to do pilot tests. Then we engaged with teachers, and in 2009, 2010, we already had beta versions of the Hummingbird kit that went into schools. And still, you know, even after that, it took another 2 years for us to get to the point where we said, okay, this is like a commercially viable product, and here's what we need to do in order to make it commercially available to people. Over the last 2 years, I've basically been collecting feedback from, you know, all of our current customers in terms of what they would like to see and where they would like the product to go. And so I launched a Kickstarter. We launched a Kickstarter just yesterday around the Hummingbird Duo, which is the next iteration of the Hummingbird kit. And that's going to be released sometime, for the Kickstarter, it'll be released in December. For general sort of sale, we're aiming for January. And so I have here a Duo controller, and I'm going to be using that for the Buildalong, but it is functionally identical to a regular Hummingbird in many respects, so it should make no difference in terms of what we do here. What it adds is an Arduino. So it's Duo because it's dual mode. You flip it, literally flip it over. There's the Arduino headers, and this also means that what we're trying to do with this is give people who haven't necessarily done any electronics or programming before, give them a platform where they can go from a very basic visual programming interface with electronics that are, all pre-soldered, pre-wired, things like this, where they don't necessarily need to know about the electronics, to a place where, through several sort of steps, to a place where they can use an Arduino kind of as a regular Arduino. So, with this side, with the Arduino side. So what we're going to do today is mostly talk through the first two steps of that, which are using the Hummingbird with the Create Lab Visual Programmer, which is a storyboarding interface that we developed, and using the Hummingbird with Snap, which is a close cousin to Scratch. And Hummingbird actually works in both Scratch 2.0 and in Snap. So I'm using Snap mostly as a personal preference, but it's really they're pretty similar. So as part of the Build-Along, I think the best way to approach this, if you have a Hummingbird kit, is we're going to start with the programming side and then kind of embed the components that we build into a simple box. I've got a box full of craft materials here, and I intend this box to actually be the box that I build things out of. So I'm going to put basically a face on this box with LED lights and a little mouth that turns. So very, very basic robot, but we've only got 50 minutes here. So, all right. So if you have a Hummingbird, take the USB cable and plug it into your computer and plug it into your Hummingbird. And I'm going to do the same. And you might hear a little ding that says, USB device connected, and your LED light should start slowly fading on and off. Now, the first thing I'm going to do with that is I have the Hummingbird kit comes with a regular screwdriver, and this is actually the piece that we're going to include in the Hummingbird Duo, which is a little plastic screwdriver that we've designed specifically for the kit. It's a little poker thing. And I'm going to connect two tricolor LEDs that are in the kit. Now, the tricolor LEDs are great because they are a single package that looks like this, and they have 4 wires coming off of them: red, green, blue, and black. And essentially what that means is that this LED has a red, a green, and a blue element inside it. And by fading the colors between one another, you can actually make any color between red and blue on the spectrum. So everything but violet, essentially. And so
let me interrupt you for a second here. Is the RGB LED in with all of the other LEDs?
Yes, the RGB LED is in the purple box, kind of maroon colored box with all the other LEDs.
Okay, I'm trying to dig that one out. Okay, I found it.
Yeah, it's got 4 wires. That's how you can tell.
Okie doke.
So yours, if they're new, will have little end caps that you can pull off the wires. And then I suggest kind of, braiding the wire a little bit with your finger by twisting. And then if you look at your Hummingbird, yeah, just like that. if you look at your Hummingbird, there's a tricolor. There are two tricolor ports, port 1 and 2, and below those you'll see an R, a G, and a B, and a minus. Now the R stands for red, the G for green, the B for blue, and the minus is kind of electrical engineering convention for black. Black is always the ground wire on all of our components. So wherever you see a minus on the board, you'll be plugging in a black wire. So I'm going to plug them into here, and I'm going to try to arrange my camera so that you can actually see what I'm doing here. So again, this is a duo. The ports are in slightly different positions, but it should be pretty apparent to you where the RGB port is, the tricolor LED port is. So to plug one in, and let me know if this isn't obvious, you know, it's hard for me to tell from here. But you want to take your screwdriver and push down on the little tab, and then push the wire in. Let me go at this angle here.
Very nicely designed.
Thanks. Yeah, I mean, we designed this so that a fourth grader can do it, right? Very easy. Like, it should be easy to do and quick to make the connection. And then once you want to push down on the little push tab, put the wire in at roughly a 45-degree angle, and then release the push tab, and then you should have a secure connection. And you can give it a little tug to make sure that it's happy in there and not coming back out. Now, one thing that one of the pieces of feedback we've received is that the wire ends fray over time, and so the Duo will actually have all solid wire ends there. So, and that's one, and I'm going to hook up both of them because I want two eyes. So you can see that there's kind of a level of abstraction going on here in the design that is, you know, slightly more more simplified than an Arduino's digital I/O ports, which is where you would hook up an LED if you were hooking it up to an Arduino directly. So here, you know, we have LED ports and tricolor LED ports, and it's clear because you have that component in the kit, you know that the tricolor LED with its 4 wires goes in the tricolor LED port, which it seems simple, but it's one of those things that is that only became clear to us after we'd had a couple of design iterations working with students. So I've got my LEDs hooked up. Now I'm going to program these to blink, and I will start by sharing my screen, and I'll let me push up a little bit here. And I'm going to launch the Create Lab Visual Programmer first and do it that way.
Okay,
well, actually, why don't
we need to download an IDE for that one as well?
Yeah. Now, why don't I ask what people would prefer? Would you like to see the Scratch-like interface, or would you like to see the interface, the storyboarding interface? Because I'm actually happy with either.
For me, either one is fine.
Well, I have not downloaded the Creator Studio one yet. I'm still connecting my my second RGB LED here.
Okay. Well, let's go with the BirdBrain Robot Server, which is the program that you need to connect to Snap and Scratch. So I'm going to share my screen, which means you'll stop seeing me and you'll see my screen. And what I'm going to do is, okay, I should now be sharing it. What I'm going to do is I'm going to go to my desktop, where if you've installed the program, you should see this little light bulb and the word BirdBrain Robot Server. I'm going to double click on that. And
okay,
when I'm launched,
still plugging in my second LED, so hang on.
Okay, I'll give it. Yeah, I know. I always do that. Just sort of. I'm so used to doing it now that that I tend to take too long.
Well, you have to sometimes poke for a second to get that wire in correctly.
Right. And you've got the new Duo board, which doesn't yet have feet, so it tends to rock a little bit.
Yeah, I've discovered that. Yes, I have to kind of anchor it down. So
that will, I mean, that's only for the beta version that you've got. That's not going.
Okay, I've got both of mine plugged in, and so now I want to go to the little light bulb.
Yeah, and double click on it.
Okay, Hummingbird not connected.
Have you connected it over USB?
I have, and the green light is on.
Okay.
Maybe I need to press a reset? No?
I'm hoping that I did send you a beta version, but try unplugging it and plugging it back in.
Okay, and so in Snap, should I see something that says it's there?
Not until you see Hummingbird connected. So with mine, you can see that it clearly says Hummingbird connected, and once it does, then I would hit Open Snap.
Okay, I'm going to close Snap.
I'm just so you know, I'm getting the same message of the neither Finch or Hummingbird is connected.
Okay. Well, try unplugging it from USB and then plugging it back in. You can leave the robot server running. So I'm going to do that. So I just unplugged it, and now I'm plugging it back in.
I'm still getting the not connected.
Do you need the power supply attached as well, or will it be?
The power supply is just for the motors and the servos. So I was going to attach it soon, but it's not necessary to attach it yet.
I know that I had the visual one running first, and when I opened the Snap one, it said not connected, so I had to quit out of the visual programmer.
Yes,
and then relaunched it, and then it connected. So.
Right, that is absolutely true. So if you can't run both of them at the same time, they're mutually exclusive. So if you have this running, and then if you've got the Create Lab visual programmer running first, and then you open the BirdBrain robot server, then yeah, it won't show connected under here because it's connected to the Create Lab visual programmer instead. So just make sure that you only have one or the other open, I guess. But in this case, since we're doing Snap, let's just open the BirdBrain robot server. So John, did that fix it for you?
Not quite yet, but I also had the.
I've got mine connected.
Okay.
I had the other one open, so yep, now I'm connected.
Okay, great, good.
Okay, and so then open Snap.
Yeah, click on Open Snap. You should say it's opening blocks, and then you'll see Imported Blocks module. And let me know when everybody gets to this site.
Okay, got to that part.
Okay. Now, like I said, Snap is a close cousin to Scratch. It's being developed out of Berkeley, and it's being used in the Beauty and Joy of Computing course, which is an introductory computer science course at Berkeley. So the thing about Snap is that it has some features that Scratch, even Scratch 2.0 doesn't have, that are more like higher level computer science concepts. So that's probably why I tend to use it. But we can use it pretty much as just like Scratch for this demo. So basically the Hummingbird blocks are actually assembled out of other blocks. So you can right click on a block and hit edit, and you can see how they're kind of put together. That's a nice little Easter egg. We've placed the Hummingbird blocks where we think, in the snap categories, where we think they make the most sense. So under motion, we have Hummingbird blocks that control the servos, the motors, and the vibration motors. Under looks, we have Hummingbird blocks that control the LED and the tricolor LED. And under sensing, we have Hummingbird blocks that get all the sensor data back. So we're going to look at the anatomy of a block, specifically the tricolor LED block here. And I'm going to zoom my blocks. It's not necessary for you guys, but I just want to make sure that people who are following along in like smaller windows on YouTube can see what I'm doing here. So this is a giant version. Oops, I'll make that smaller. Now again, Snap can be used just like Scratch to make games or play music or make programs that make animations, but here we're going to focus mostly on the use to control the Hummingbird. So the Hummingbird Tri-LED block has 4 arguments, 4 numbers. Now the first one, and this is true for all Hummingbird blocks, the first number is always the port that we're on. So we actually have 2 LEDs. So 2 tricolor LEDs. So I'm going to pull one in at 2 and one in at 1. And then the 3 numbers, the RGB, that's the intensity in percent of those 3 different color elements. So by default, if you click on a block, and you can actually just click on one and it should turn on the LED. The default number is red 0, green 100, blue 0. So it's going to turn your LED to green. Now, if you want to try mixing some colors, you could change, make blue.
Let's see. I'm clicking on I've got a block set up, and I'm clicking on it, but I'm not seeing any action.
Okay.
So you should just click on the block to see it happen?
Yeah, if you click on it, and you should see like a blue-green kind of border just for a second as you click on it.
It flashes, yeah.
Yeah, and
the border flashes. But I'm not seeing anything happening with the lights.
Huh. Can you check?
So let's see.
Does your the Birdbrain robot server show that it's connected?
It did when I...
Yeah, can you open that window again and just double check that it still is?
I'm sorry, which window is that?
That's the little light bulb window.
Okay. Yeah, Hummingbird connected.
Okay. And so when you click on these blocks, it doesn't do anything, huh?
It quit. I'm going to reopen it.
Okay.
Huh. For some reason, it keeps quitting on me.
What quits on you?
Birdbrain robot server quit unexpectedly. Click reopen to open the application again.
Are you running in Mac or Windows?
I'm in Mac.
Okay. Huh.
Am I going to try it again?
Yeah, please do. It could be that the version I sent you is the Duo, which has been tested less. So it's entirely possible.
I've got the Hummingbird connected.
Mm-hmm.
Do I click on Open Snap even though I've still got it open?
If you've still got it open, you can leave that alone. You don't have to click on Open Snap again.
And I quit again. Huh.
All right. I clearly should have just sent you, the current version instead of sending you the beta version. So I apologize for that. Is everybody else okay?
But don't forget, if you want to talk, to unmute.
Oh.
Yeah, I'm good.
Okay.
Me too.
Yeah.
Well,
So
just continue, and I will continue messing with it to see whether I can get it working.
yeah, and I will send you a current version of the like a version 1 board also, just to make sure. I haven't tested the Duo as much under Mac yet, so it could be some strange condition in the software right now.
Yeah, it just keeps quitting. So I'm just gonna listen along here.
Okay. All right. So let's say we've got the tricolor LEDs. So like I was talking about the sort of the arguments sent to the block. The first one is the ports, and then it's red, green, and blue. So what's nice about Snap and Scratch as well is, just clicking on a block lets you see what happens. And so it's very easy to mess around, change the numbers, and see what kinds of colors you get with the LEDs. So let's say that we want to make these LEDs blink, which is pretty popular. I like making things blink. So for that, we can use some regular control structures, which are included in the control menu. So I'm going to start my program when I hit the space key. And I'm going to use a forever loop, which is a loop that runs, forever, or at least until I hit stop. And then I'm going to turn my LEDs on and off. So one thing that students often do, let's just do one LED, is they'll often put together something that looks like this. And they'll turn one of them off, they'll set the numbers to 0, and they'll set the other numbers to what they want. And if we hit space with this, you will see your LED go into super flashy mode. So it's now running as fast as possible, which means that it's basically executing these blocks. These blocks take about 15 milliseconds each to execute, so it's executing this loop probably 30 times a second. So that might be a little bit uncomfortable, like a little too flashy. So we can go into control and we can put weights in. So if I put in, this is sort of the second common error, I just put in one weight, and then you can see that it turns on for a second and then turns off for 15 milliseconds or so. So we actually need a weight after each block. And now we're blinking it 1 time per second. On for a second, off for a second. And we can change this while the loop is running. So if I want to change, how fast it's going, anything like that, can do that. So
by the way, it seems to be some kind of Java error is the problem.
Okay. Yeah,
maybe I need the latest Java.
That's possible. Yeah, that may help. Do you know what version of the Mac operating system you're running?
It's an older one on this computer.
Okay, because we support 10.6 and later, so if it's very old.
10.6.8. So.
Huh. That's the same version that I use. Okay, I definitely want to. Well, after the Hangout is done, I definitely want to debug your particular case, because I have a machine that's 10.6.8 that I use all the time. So that's very mysterious. But okay, let's keep going here. All right, so we've got our blinking LED now. So I think the next thing we should do is add some servos and motors, or just a servo, because for our very simple robot, we just need 2 LEDs, a servo, and a sensor. So I'm going to get a servo. And at this point, you're going to want to, well, the first thing you'll want to do is plug in the servo. Now, I'm going to switch back to the camera so that you can see me do this. For a sec. Okay. So the servos are down here. And if you look closely at the servo cable, it has 3 wires, and it's yellow, red, and black. And if you look at the servo port, it's sort of a 3x4 metal grid of metal posts. And if you look there, you'll see an S, a plus, and a minus, and also a Y, an R, and a B. And those are hints to tell you kind of how to plug in your servos. So S is for signal, which is the yellow wire. Plus is for red. Black is for minus. Also, the YRB should give you a hint. So I'm going to plug my servo into port 1. Then I'm going to make sure it's correct and plug in my power. So all Hummingbird kits have this extra power for running motors and servos. When I do that, my LED, my orange power LED should turn on. All right. So I'm going to go back now to the program and show you how to actuate that. All right, everybody good with hooking up a servo and power?
Yep.
Okay. So again, to control the servo, I'm going to go into the motion category and pull out my servo block. Now the servos in the Hummingbird kit get used a lot more than the DC gear motors. And the reason for that is because they're really easy to use as ways to make like mechanical arms or eyebrows or things like that, because you can set instead of a gear motor where you're setting the speed of the motor, with the servo you're setting the position of the motor from 0 to 180 degrees. So they don't actually rotate entirely all the way around. So again, the servo block, the first number is the port, so 1, 2, 3, or 4, because we have 4 servo ports. The second number is degrees, between 0 and 180. And this is true for all of our blocks, but if you were to put in a number here that was, below 0, it would round to 0, and above 180, it would round to 180. So just
Tom, how do you know which port you want to use?
It's up to you. You can set it, you can set it in the program. So I plugged mine into port 1 because that's kind of the default. But you can use whatever port you want, and you can plug in multiple servos and then control them from multiple ports. So if you want you may have a servo on port 1, another one on port 3, and then you would use different blocks to control those. You'd have one at 1 and one at 3. Now, with the servo block, if you click on it again, it'll go to 0 degrees. If you want to see what 90 degrees looks like, you can change that and click on it again. You can also, like before, pull this into the already running blinking loop and pull in another one. And now you should have a servo that's going back and forth. Now, the servo takes about a second, and you can probably hear it going right now. So the servo takes about a second to travel its full distance. So, telling it to go from one position all the way to the other position in 0.2 of a second is kind of cruel to it, because it can't actually do that.
Tom, since I don't have mine working, is the LED blinking simultaneously with the servo?
Yeah, the way that in the loop that I have running right now, yes, it's blinking simultaneously. Now you can structure all sorts of different programs. Like you could run, the servo independently of the tricolor LED as well. So let me stop the servo, just so that we don't have to hear it go back and forth all the time. But
is there a toggle so that you can see the code that goes with the visual blocks?
So in this case, no, because there is actually no underlying code. What the blocks are composed of other blocks. Like if we go into here, you can actually see what the blocks are made of. They're made of other snap blocks, and those blocks are then sending sending commands over HTTP to the server, to this, and that server is talking over USB to the Hummingbird. So there isn't actually any kind of underlying code in this particular case. Now with the Duo, we are planning the Duo is Arduino compatible, so you can run it as an Arduino. And one of the things we're thinking of doing is for our other programming interface, creating a code converter. So you could convert visual programmer sequences into Arduino programs. So then we would have sort of a text-based code converter in that environment. In this one, it's a little trickier for a bunch of technical reasons, mostly around multi-threading. But we may still try to figure out a way around that. We haven't decided yet. But yeah, we would really like to do code converters so that kids who do these kinds of graphical environments can look at actual underlying, or can see what it looks like in a text-based programming language, and then go on to edit it in that text-based programming language.
Tom, just a quick comment and a question. This is awesome. I've been playing with Arduino with middle school kids for some time now, and as fun as it is, it's also there's a curve. Mm-hmm. There's a learning curve, and to get this up and running so quickly, and the fact that it's very scratch friendly, it's awesome. This is great.
Yeah, I agree. I agree. Having played with the with other kits that are just not engineered as nicely as this is really plug and play.
I do have one question though. Scratch has the offline editor, and does Snap also have an offline editor?
So they don't, but we've built in an offline mode into the robot server. So if you look here, there's an OpenSnap locally, and what that is it's basically when you install our robot server, you also install a local version of the Snap website that we downloaded. Most recently in April, I think. So there is a local mode. And we did that precisely because a lot of schools need to use offline mode. So, yeah. And actually, at present, we only work with for Scratch, we only work with the offline mode. Okay. That's something that they're working to get hardware extensions into their online mode, but it's very experimental right now. So.
We've just noticed that the offline editor performs better, so that's why I ask, and that's great to know.
That's fair. Okay, so the last thing we have to add to this is a sensor. So I've got here the sensor that I use most often, or that's kind of simplest to understand, is the light sensor. So let me go back to the camera mode so that you can see me and see what the light sensor looks like. Okay, there I am. So the light sensor has this, it's very small, it's this little ceramic disc with a squiggly line. And the idea with all of our sensors, we have the same 3 wires coming off the sensor. And like the servo, they're power, which is red, ground, which is black, and the signal wire, which is yellow. And so to hook those up to a sensor port, you would go from, black would go to minus, red would go to plus, and yellow would go to S. Now, if you look at my Duo, let me pull this down here. The sensor ports are blue, and that's the first step in something that we aim to do generally, which is to color code all the ports. So on the new boards, sensor ports will be blue, vibration motor ports will be yellow, and motor ports will be orange. LED ports will still be green, just to give it like an additional tip as to where to plug in what. Kind of a minor upgrade, but one that I'm, for some reason, very excited about. Like the idea of having a colorful board. So I'm going to hook up my light sensor to port 1. Again, black to minus, red to plus, yellow to S. And so once I have that hooked up, let me go back into Snap. And I'll go into the sensing category. And I'm going to pull in my Hummingbird light block. And if I just click on that block, I'm going to get a value that is, in the case of the light block, it's going to range from 0 to 100. And in this room, with these lighting conditions, if I point the sensor up, it's at around 40. If I cover my sensor completely, I can get it to go down to like 1 or 2. So the different sensor blocks have different ranges. So for example, the temperature sensor, if I hook that up, it would give me temperature in Celsius. Or if I wanted to use Fahrenheit, I could get Fahrenheit. I have a distance sensor. If I hook that up, I could get distance between 10 centimeters and 80 centimeters. There's a little knob, and that range is just 0 to 100. And then there's a sound sensor, which is mostly like a clapper. So, you know, if there's no sound, it reads 0, and then if you clap or scream at it, then it'll read a value. So, so again, the light sensor is pretty easy to use. One of the neat things that you can do with the light sensor is to just have the light sensor control an LED directly. So let me do that. I'm going to stop the loop that I'm running right now with the servo, and I'm going to make a new loop. So I'm going to start this loop when I press a different key. So let's say L for light sensor. And it's going to be a forever loop. And I'm going to pull in my tricolor LED block. I'm going to put the light sensor block into each, well, I'm just going to control the green with it. So red is 0, green is set to the light sensor value, and blue is 0. Now what's nice about the light sensor is its range is 0 to 100, and the range of my LED, you know, to control the intensity of the LED, that's also 0 to 100. So I don't have to do any multiplying or dividing or adding or subtracting to get the value of this sensor into the same range as the value of the output. If I did have to do that, then I could go into operators and use the operators to do that. So I'm going to press the L key. And now, if you've done the same thing, you could cover your light sensor, and you should see your light dim or go almost to 0. And so now you have a visual indication of the light falling on your light sensor. And what's interesting is if you point your LED on your light sensor, you can actually get it to brighten.
What happens if you press the space key?
If you press the space key, now every now and then you'll see your LED blink. So that's kind of a neat thing about Snap and Scratch is you can run multiple programs, kind of multiple threads doing different things. And so in this case, what's happening is the loop in the L key is running kind of all the time. So it's running constantly. Every 15 milliseconds, it's taking the light sensor value and applying that to the green LED intensity. In the other loop, we have the tricolor LED, and it's being set to kind of a blue-green, and then we wait a second, during which the L loop is running, and so it goes right back to green. and then we set it to off. So what you'll see is every second you'll see your LED flash when it's being set over here. So this can lead to some, if you use this multi-threading it can lead to some pretty interesting behavior. But it's behavior that you can debug visually. You see it and you see, okay, why is that flashing? And then you kind of think about it. You kind of realize, oh, it's because both of the loops are running at the same time. Maybe I shouldn't be doing that.
Tom, I have a question. I hooked up the sensor, and when I did that, I got a USB is drawing too much power error on the Mac.
Oh. Check if you have. So this is one reason that we got rid of the wires frame. So unplug your USB port and take a look at your sensor and make sure that there's no little tiny hairs, like little metal hairs, connecting the black port, the black wire, and the red wire. And also make sure that you've got the wires in the right place. So the black wire to minus, the red wire to plus, and the yellow wire to S. And once you've done that, plug USB back in. You may have to restart the BirdBrain robot server, depending on your kind of situation.
Okay. I'll give it a try.
Yeah. So if you are able to, like, if you accidentally short the plus and the minus, you could get that error. And I mean, it doesn't do any serious harm, but you definitely want to unplug things and make sure that it's fine. But again, that's why we now have the metal wires, or the metal ends on these wires, to make sure that fraying doesn't happen anymore.
This might be a very stupid question, but I was thinking, is this now running on your computer when you're in Scratch, and is it like sort of like Scratch for Arduino or something like that?
It is right. So no, that's a great question. So at present, the current Hummingbird is a tethered device. So you're leaving it plugged in over USB. So it is running kind of like a Scratch for Arduino, where there's a fixed firmware on the microcontroller board, and then you're just talking with it over USB, and all of the programs are running on the computer. So with the Hummingbird Duo, we will have the Arduino mode, where you can download a program, like basically overwrite the firmware, but you won't be able to do that within the Scratch interface or the Snap interface, at least until we figure out a way to convert the code into Arduino code.
And for that conversion thing, did you consider ArduBlock?
We haven't looked at ArduBlock yet. We've looked at ModKit, and we maybe that's something that we may consider. I can't say too much because I don't want to promise things that may or may not happen at this point. We don't know yet. With the visual programmer, with our other programming environment, we're more certain that we can create a code converter that will go into standalone Arduino mode.
Okay, cool.
So John, did that work?
It did. Things came back.
Okay, good.
So now I'm just trying to. I threw the Hummingbird light code into the blue, for example.
Mm-hmm. Right.
And so I should just see, as I cover the light, I should just see the light change, the LED change.
Right. As long as that loop is running. Yep.
Great.
One thing that's nice to also see, if you want to see the sensor value kind of posted as a number and running constantly, one way to do that is to create a variable. So let's call this variable light sensor, to make it very clear. And then in my loop, I can constantly set light sensor to the Hummingbird light port. Oops. Now, let me just see if I have to rerun that loop. Yeah. And then I can actually use, since I now have a variable, I can use the light sensor variable instead of the light sensor block. Now the reason that you might want to do that, one, you get that cool monitor, showing you what the value is. And it's kind of, the graphic is kind of screwed up on my screen because I've zoomed the blocks in so much. But another reason that you might want to do this is think about timing. So each time you call the sensor port, the Hummingbird light port, each time you call that, that's 15 milliseconds. If you set it to a variable once and then use that variable all over the place, like if you're using that variable in a bunch of operations, or if you're setting all three of these, your loop is basically going to run faster. So, for example, if I wanted white light instead of green light, I could do that.
Can you show us your screen, Tom?
Oh, sorry, I thought I had it up.
Yeah, no.
Sorry.
I
switched back. I'm so sorry. Yeah. Thank you for telling me.
Okay.
So yeah. So you can see kind of the value changing over time. All right, now we didn't get to this. I see that it's already time is almost up. But what we have here are the robot guts, right? So in order to make a robot with this, basically just any other crafts project. So if I wanted to, let's see. All right, I'm gonna bring back this. Okay, so you can see me. I've got a box, standard cardboard box, nothing special. If I want to embed some LEDs, I might take an X-Acto knife or something else. Cut a hole. Cut another hole. Stick my LEDs through the hole. Okay. So I've got the beginning of a face, So if I want to...
It's alive!
Yeah, exactly. I might cut like a little rectangle for my servo, stick that in, put some, I've got these pipe cleaners. These are great mouths. Like you just stick them on the servo. Now your robot is either happy or sad, right? Like stick it on, turn it 180 degrees, now it's a sad robot. Make your eyes blue. So very simple, basic idea here, but you can also make incredibly complex robots. Like if you need examples of that, you can just go to the website under Learning, under Example Robots. You can see all sorts of things that kids have made, and basically the more time you give them, the more awesome things you get. Because of the tethered nature of the Hummingbird, because it's always plugged in with power and USB, almost all the robots we've seen so far have been kind of in the animatronic diorama robot theater kind of things. So things that fit on a desk that work that way. We've seen a few things that drive, like an R2-D2, but there's very limited range because of the length of the cords. The nice thing about the Duo is that you will be able to run it in standalone mode, and so we might see more kind of robot rovers and those kinds of robots. The power for Hummingbird, like this power, we ship it with a wall power supply, but it's very easy to get a a 4 AA pack with that coax cable connector, which will run it just fine. So 4 AA batteries will run the Hummingbird just fine too. So you can make it completely tetherless. Some ways that people have made Hummingbird tetherless so far have been just to use like a Raspberry Pi or things like that, like a Raspberry Pi as the computer. So that's another way that you can make it tetherless now with your existing.
So like Arduino, once you have downloaded or uploaded code, it will continue to run that, even if you're not plugged into the computer, if you have a power source?
Yeah, with the Hummingbird Duo, if you download a program, like an Arduino program to it, it will run it, and you know, as long as you've got power, it'll run it, regardless of where the power is coming from, whether it's USB or whether it's coming from the power port on the, like the motor servo power port.
And Tom, is there a voltage regulator on the board? The reason I'm asking is, could you put a 9-volt battery pack?
Yes, you could. There's a voltage regulator on the board on the Duo. On the original Hummingbird,
okay.
on the original Hummingbird, the motor power port just powers motors and servos, so it didn't need to be regulated. But on the new one, it can power the entire board. If USB is disconnected, it powers the whole board, so we have a voltage regulator on it for that. One reason not to use a 9-volt, one reason not to use a 9-volt though is the servos themselves have kind of an ideal voltage range between 4.8 volts and 7 volts roughly. So you don't, like, if you're using 9 volts, you're kind of overpowering them, and they'll be unhappy. They won't really die or anything, but they'll be unhappy about it.
Okay. So just to clarify, on the original Hummingbirds, the LEDs wouldn't light up then with a 6-volt battery pack?
Well, with a 6-volt on the original Hummingbird, the LEDs are powered entirely from USB power.
So we couldn't untether at that point.
Right. You can't. Yeah, untethering it won't work.
Okay. Thank you.
Sure. Any other questions like that? I think we've only got a couple minutes left, so.
No, this is fantastic. I think we probably all want to do more. Tom, I don't want to prevail on your time too much, but you're certainly welcome. But the rest of you, if you're interested in continuing playing with the Hummingbird, do it in a kind of peer-to-peer fashion, see where we can go from here, I can set something up. What I suggest is that you email me, howard@rheingold.com, and I will set up a little poll to see what date and time might work for most of us several weeks to a month out from now, and then we can continue this if you'd like. So if I get if 3 of you are willing to do that, I'm happy to do it. And Tom, as I said, I don't want to prevail on you too much, but you are certainly welcome to continue showing us. So let me know. We'll set up a poll, see whether we can go from here, because this is great. This is, I think, we all agree, the engineering on the kit is fantastic, especially if you've tried other kits, and the combination with the visual programming language is pretty cool.
Thanks. Yeah, and no, this was really fun, so I would definitely be interested in joining again, and I also want to help debug your problems, so we'll get that sorted definitely before the next time. Okay,
well, I'm going to just try to update my Java and see what that does.
Yeah, that's a good possibility, but.
So are you a one-person outfit, Tom, or you got other people working with you? Because this is a pretty well-developed kit you got here.
Oh, thanks. So it's there. I have a business partner who's working on the sales and marketing end right now. And I mean, bear in mind that while I'm the only one sort of on the commercial end in the design space, there's a big team behind it at Carnegie Mellon that developed a lot of the software. I was the hardware designer on the project when I was a PhD student, so that's why it kind of made logical sense for me to take it and put it into manufacturing, because manufacturing is a lot about hardware design. So while it's kind of a 1 to 2 person company, there's, you know, like I said, there's a big team at CMU, and there's a lot of consultants, manufacturers, and contractors that help out, sort of. So it's a network more than it is, I guess, a staffed company.
Great, wonderful. Thanks so much.